Greetings and welcome to episode 12 of the Sustaining the Herd podcast, brought to you by Sechi Agri-Services and Engineering of Raymond, Nebraska. I'm Andrew Wadle, the Director of Innovation and Sustainability at Sechi Agri-Services, and joined in the studio here with my co-host, Barak Vitek, as well as our special guest, Charles Love of Trillium. And in a moment, we're going to give Charles a chance to introduce himself and talk more about Trillium. But for our new visitors, it's important for you to kind of get a feeling for what our podcast is really all about. And it really involves all things involving sustainability in animal agriculture. And sustainability means a lot of different things. It could be environmental sustainability, that being, keeping manure and other contaminants out of the air and water. We can have sustainability can mean utilizing resources, and that is getting the most of output for every unit of input. So, and it could mean sustainability involves taking care of animals. The longer we keep animals in herds, that's a function of sustainability. And lastly, sustainability can be financial sustainability. So we have to have businesses that are successful and vibrant and making money. And so we want to touch on all these things as we go through our episodes. And in this particular episode, we're really going to try to tie together the concepts of environmental sustainability, utilizing resources, and the financial aspects of being sustainable. So whether you are someone who's in production ag, we hope to offer information that can help you run your business. And if you're a person from town, so to speak, we want to tell you all about the agricultural industry that we love and really prevent there from being any myths about agriculture that go unchecked. With that, I'd like to introduce you to our guest, Charles Love.
Sure. Well, thank you for the introduction, and it's a pleasure to be here today speaking with you. I guess, a little background on myself. I started my third company when I was 21 years old. I moved to Southern California from Oklahoma, where I was born and raised, and started a seafood business. And after 5 years in the business, I changed careers and was ready to start another company. And my wife said, "Why don't you try working for someone else for a change?" And so I ended up pivoting careers, going from the fish business to the CNG RNG business. And that's what I do today. I manage the RNG portfolio for Trillium, which is a member of the Love's family of companies. I'd be happy to discuss a little bit in detail later.
Outstanding. Well, thanks for introducing yourself, Charles. And you mentioned that you work with Trillium. So could you tell us and all of our listeners a little more about Trillium?
Sure. Trillium was founded in 1994 and has 30 years of experience in the alternative fuels industry. We own and or operate over 220 compressed natural gas, what some people refer to as CNG stations, and renewable natural gas we call RNG. And around the country, we have a wealth of experience building and operating hundreds of alternative fuel stations, including hydrogen, which is liquid and electrolysis, EV charging, as well as RNG and CNG stations. We provide engineering, construction management, operations and maintenance, and fuel supply services for transit agencies, municipalities, trucking companies, and waste haulers. So Trillium is a member of the Love's family of companies, which most people are familiar with. Love's travel stops and country stores you see on the highways. Love's is a family-owned and operated business founded in 1964 by Tom and Judy Love, headquartered in Oklahoma City. They opened their first gas station in Watonga, Oklahoma. And back in 1964, most of the stations had service bays and they weren't like you see today. They soon realized they could close the service bays and convert that space into a mini store and sell groceries as well as like fresh made deli sandwiches. Imagine back in the early 70s, before Subway came around, you could go to your local Love's Country Store and get a fresh Subway sandwich. Anyway, the Love's family of companies include Love's Travel Stops and Country Stores, Gemini Transport, which is our trucking and logistics business, Musket, which is our fuel trading business, Speedco, which is light duty truck maintenance, and then Trillium, which is alternative fuels. But the sum of these companies provide a wide range of fueling solutions for heavy duty fleets. So in addition to CNG and RNG, we sell obviously biodiesel, renewable diesel, diesel exhaust fluid, tires, tire management, light truck maintenance, factoring, fuel transportation, logistics, everything, from heavy duty fueling solutions to light duty solutions. And when you tell people that you work for Love's, the most people have something to say. They say, "Oh, I love Love's." That goes to the core of our trademark brand customer service, which is clean places, friendly faces. And the Love's difference is the dedication to treating each other like family and taking care of each other. And really, that's part of our core values. And we're always hiring. We're always looking for people. So jobs.loves.com. Apply today. We're always looking for good people. But that's my plug for Love's.
Well, that's really great, Charles. So what inspired Trillium to explore and pursue biogas opportunities?
Sure, great question. We first started buying RNG and providing offtake agreements for biogas producers that were really looking to access the Renewable Fuel Standard, which is the federal program administered by the EPA that was established by Congress and to incorporate domestic fuels into the fuel supply. And also we access like the low carbon fuel standard markets out in California, which is a program that it's administered by the California Air Resources Board.
Charles, as we get further into the conversation, there are many acronyms such as LNG, CNG, RNG, sometimes what Andrew and I refer to as the alphabet soup of biogas. Could you describe the differences between LNG, CNG, and RNG for our listeners?
Sure, absolutely. LNG stands for liquefied natural gas. And when you refrigerate natural gas to minus 260 degrees Fahrenheit, it drops into a liquid form. And it's transported, imagine, and stored in these big giant thermos bottles. There are 12.1 LNG gallons per MMBTU. So the energy content is different than, let's say, compressed natural gas. Compressed natural gas has an energy content of 125,000 BTUs, and that's what's called a CNG gallon. And also a diesel gallon equivalent, DGE, has 139,000 BTUs of energy. And so there's 7.19 diesel gallons per MMBTU. And then RNG stands for renewable natural gas. And renewable natural gas is the same as its cousin. So CNG is, let's say, fossil-derived natural gas. And RNG is natural gas that's derived from the breakdown of organic matter, biogas. So when organic matter decomposes in an anaerobic environment, it produces biogas, and a certain percentage of that biogas is CH4, which is pure methane. You have to remove the CO2, and depending on the feedstock will depend on the quality of that biogas. I mean, I could talk a little bit about the various feedstocks, or would you like to cover something else?
No, please do.
That'd be great.
So you can make renewable natural gas from manure, which you guys have been talking a lot about. So cow manure, you can put it into a covered lagoon, which is you basically just cover the lagoon and you create an anaerobic environment, and they siphon off the raw biogas and clean it up to pipeline quality. Or you can put it into like a CSTR or some sort of mesophilic or some sort of digester to heat the digester and create those environments to create the biogas. So that's like a manure operation, whether it's swine or cows. You can create biogas from wastewater. When municipal wastewater sludge, you can create biogas from that. You can also create it from food waste or agriculture waste. Same thing. Put it in some sort of digester. Landfills also create biogas. So when they cover up all that trash people throw away, they throw away organic matter and it decomposes. Once they cover up all that trash, they create an anaerobic environment and they drill wells. So imagine drilling a hole in the ground and putting a series of pipes that are laid horizontally, and then they create the vertical wells. And gas methane, CH4, is 17 times lighter than air, and so it finds the path of least resistance. They pull a slight vacuum on those what they call well fields, and they pull the methane up that way, clean it up to pipeline quality, and inject it into the local pipeline.
And this is kind of an interesting note for our non-agricultural people and maybe our listenership in general, and that is, can you just describe the difference between methane derived from fossil sources and methane derived from manure?
Sure. So chemically speaking, when you drill a well and you produce natural gas out of the ground, the methane content of that raw biogas coming out of the ground is very high. It's called high BTU gas. And the methane content from a manure operation, the methane content might only be, let's say, 55% or something. And the remaining constituents in the gas must be removed to create what's called a high BTU end product that is molecularly identical in terms of use as fossil natural gas, because you're achieving that what's called pipeline quality biomethane or renewable natural gas, aka RNG.
So I guess we could say the methane is indistinguishable. The difference is really just the methane content of what we'd consider to be the raw gas.
That's right. And that's a common question that people ask when we talk to them, when we talk to fleets about converting over to renewable natural gas. They say, well, is it going to ruin my engine? Is it going to impact my station? And the answer is no, it's not. Why? Because the molecules being delivered to the end user are the same molecules that you're currently purchasing from your local distribution company or local gas supplier. The molecules are the same. When we inject pipeline quality into the grid, that's what we call the pipeline system around the country, the grid. When we inject that pipeline quality gas into the grid, through mass balancing, book and claim, we purchase pipeline quality at the end user CNG station. And through a contracting process, we transfer title from production to end use that's acceptable for the EPA, which administers the Renewable Fuel Standard, the RFS program, to allow for the generation of what's called a Renewable Identification Number, RIN, aka RIN credit. And those RIN credits are purchased by obligated parties under the RFS, under the Renewable Fuel Standard.
So we have the gas, and we have it cleaned up to a point that it's at a filling station, but still we have this issue of what could be some of the technical limitations, because we've been running engines on on fossil fuels, gasoline and diesel for a long time, maybe 100 years or so in our country. So, what are some of those technical limitations, and how are they being overcome?
Sure, that's a great question. Diesel is the over-road fuel of choice. I don't know how many tens of billions of diesel gallons are consumed annually by over-the-road trucks, but it's a massive number. And when fleets, so this is really a fleet question. When fleets look to change over to renewable natural gas, CNG for their fleet, they really you have two classes of fleets. I like to say the different customers or classes out there. There's the transit customers, which are the buses. There's the waste haulers, which are the trash trucks, picking up your garbage. And then the trucking companies. Well, when you look at CNG as a solution for a fleet, in the past, based on limitations that the larger engines were not available, let's say 4 years ago, you could not buy the new Cummins 15-liter engine, which you can buy today. So a waste hauler fleet could use the 9-liter or the 12-liter engine. A transit bus could use the 9-liter or the 12-liter, preferably the 9-liter. And so those markets were perfectly suited to adopt CNG. And those markets are served primarily what we call in the business private stations. So these are behind stations, CNG fueling stations that are behind the fence. They're not open to the public. If you got a CNG truck and you pull up to a private station, you can't get in because you don't have access. And so now that we're looking at the over-the-road trucking market, it's changed the needs. So the 15-liter engine, you couldn't buy it 4 years ago for the over-the-road market. Now you can. So Cummins has come up with the 15-liter engine. And by the way, these engines are super clean. So the 9-liter, the 12-liter, the 15-liter, these engines are super clean. Remind me to come back later and tell you about how clean they are in terms of NOx emissions. But these over-the-road fleets, what we call, these trucking companies that need to go from Texas to California and then maybe up to, Oregon and then back to Texas, those trucks need public access stations. And now that the 15-liter engine is testing very well, we're getting a lot of positive feedback in the industry from people that are using these trucks. It looks like the 15-liter can handle what we call the over-the-road market. And if that is the case, you're going to see greater and greater adoption by companies looking to reduce their carbon footprint for their fleets. Because when you compare fossil natural gas to renewable natural gas, one is derived organically, one is fossil derived, but also the organically derived renewable natural gas has a lower carbon intensity. So it's a cleaner transportation fuel. The carbon intensity of the feedstock determines where the fuel is consumed in the United States. So California has something called the low carbon fuel standard. And under the low carbon fuel standard, there's an incentive to have a lower carbon intensity for your fuel. You can generate more LCFS credits the lower your carbon intensity is for your fuel. So fossil derived natural gas has a carbon intensity of, let's say, 80, give or take. Landfill gas has a carbon intensity of, let's say, 40 to 50, give or take. Wastewater treatment plants have a carbon intensity of, let's say, 20 to 30. Food waste facilities have a carbon intensity of like 0 to minus 20. And then a dairy operation or a swine operation, depending on the type of digester, whether it's a covered lagoon or a heated digester like a CSTR or mixed flow, will have a carbon intensity of minus 150, minus 250. because they get a methane avoidance credit under the program, which uses the GREET model. And so they get a credit for avoiding putting this methane into the atmosphere, because methane is what's considered to be a short-lived climate pollutant, SLCP. And so methane, 1 ton of methane removing from the atmosphere is equal to removing 25 to 65 tons of CO2, because CO2 has a long-lived climate pollutant as opposed to methane, depending on which model you use. And so there's an incentive to send these low-carbon fuels into California.
And so we're going to talk a little bit more about the contracting process, and I think that really the CI discussion could come up again there. From the standpoint of actually fueling trucks, if we were to go the route, the over-the-road route, and the engines work out the way we anticipate, how are we doing as a nation in terms of having the filling stations? So here we've got these engines. Well, now can we get across the country and have adequate filling capacity?
Well, I think that's a question that is determined on a route by route basis, per company by company. And that's really where you get into the nitty gritty of this business, because that's really our focus in the supply chain. We're not developers, we're not farmers, but what we're good at is building alternative fuel stations. And that demand comes directly from our customers. So as customers look to reduce their carbon footprint, as customers look to achieve their green initiatives or their carbon reduction efforts, that's what's driving the demand on the RNG side of the equation. And that's what we're good at, finding those solutions for our customers and building those stations so that when our customer is ready to buy trucks, they've got a network to go from A, B, C, D, E, F, G, and then all the way back to A, fueling in our network.
That makes sense.
Charles, we've talked about what RNG is and how it's produced. You also gave us a great description of some of the limitations and barriers to adoption for natural gas to become a more commonly used transportation fuel. And then we briefly talked about the contracting process, and I'd like to dig into that more. Could you help us understand that contracting process from the time that RNG is injected into the pipeline at the dairy farm or the swine farm, all the way to the time that it is dispensed by a truck driver at a filling station?
Sure, that's a great question. So the contracting process we use, the base contract is the North American Energy Standards Board. I know that's a lot. We call it the NASB for short, but that's the base contract that allows us to buy and sell kind of commodity natural gas. And then we have special provisions to the NASB, which an attorney drafted, that changed some of the provisions of the NASB. But the real key ingredient in this transaction is what we call the biogas addendum, and that allows us to buy and sell RNG. And then the final piece in that contract puzzle is called a transaction confirmation. And the transaction confirmations have all the details about the price, the volume, the delivery, the term. All of that is found in the transaction confirmation. And so, as I mentioned earlier, through book and claim, we inject gas into the grid, and then we purchase gas downstream in the grid. And through these contracts, we transfer title from production to end user.
Very good. And just for our listeners, Charles, who may not be familiar with what I'll call the black box of that RNG goes into once it enters the pipeline, could you help us better understand book and claim accounting that, the physical molecule of RNG produced at a dairy farm in Nebraska, for example, may not be the same physical molecule dispensed at the filling station in California, but on paper, that's been tracked. Could you dig into that a little more?
Yeah, I get asked this question all the time. And the example I like to use to help explain it to people is this. Let's say you're in Nebraska and you got $100 bill in your pocket, and you literally go to an ATM and you put $100 bill into an ATM in Nebraska. And then you're out in California, you're out in Los Angeles, Beverly Hills, on a tour with the stars, and you go to an ATM and you take $100 out of the ATM. It's not the same $100 you put in the ATM in Nebraska, but it's your $100 you're allowed to take out in California. The same thing works for environmental attributes. You put them in the grid in point A, and you can physically take them out in point B, C, D, or E along the grid, as long as you've contracted it properly, as I stated earlier.
That's a great analogy, Charles. I know that helps me think about this in a clearer way, and I imagine our listeners appreciate that analogy as well. I'd like to follow up on our contracting discussion here. Earlier, you also talked a little bit about CI score, or carbon intensity of gas. And for all of our listeners, especially those who work in production agriculture, the farmers who are listening, how does what takes place on the farm and in the anaerobic digestion process impact how the gas is marketed once it enters that pipeline?
Sure, that's a really technical question. So there's something which you guys are experts in called manure management practices, right? And so the dairy's manure management practices are considered by, the Air Resources Board, the California Air Resources Board, CARB, as your baseline. And so one dairy's baseline can be different than their neighbors depending on their historical manure management practices. And so based on, the solution you find to get that gas into the pipeline can have a great impact on your carbon intensity score.
Excellent. So, I think that as more and more companies come into the space, and as our society as a whole becomes more tuned in to sustainability, more companies and more innovators will come into the space of RNG. And we've talked a lot about RNG as a motor fuel. If you were to look at your crystal ball, Charles, and kind of dust it off, and what do you see the future looking like in terms of what are some of the other things that we will be doing with RNG in the future?
Sure. RNG, in my opinion, is the perfect alternative fuel. Why? It can be used to make other fuels. We talked earlier about liquefied natural gas, right? When you refrigerate it to minus 260. You can use RNG as a feedstock to make LNG. You can use it to make CNG, dispense it at 4,000 PSI into a truck, bus, or other vehicle. You can use it as a feedstock to make hydrogen, to make green hydrogen through steam methane reforming. You can use it as thermal heating value, right? You can cook your dinner with it if you wanted to. You can use it as a process ingredient in chemical and other manufacturing processes. Or it can be used to provide power 24/7, 365. A lot of these projects, they're producing biogas 24/7, 365. So it's rateable power. You can make electricity with it and put it onto the grid. So it's really the perfect alternative fuel. And that's why you see companies investing billions and billions of dollars in this space, because RNG can help you lower scope 1, scope 2, and scope 3 emissions. So it's a good fuel that recycles our waste. When people ask, what do? I say, we recycle your waste. We take your waste and we recycle it into another form of energy that we can use. I personally specialize in transportation, but you don't have to limit yourself to transportation. You can do so many things with biomethane, RNG, biogas that you can't be limited. There's a company that even runs it through a process and creates electricity without combustion. They run it through like a fuel cell and create electricity. RNG is a perfect feedstock.
Yeah, and I'm just going to still that down even a little bit farther for our listeners, and that is, so you have this renewable natural gas that's being made, and so capturing that renewable natural gas is avoiding an emission that would otherwise go into the atmosphere, while at the same time we are producing a fuel. Is that fair to say, Charles? It's almost double dipping, but not double dipping in a bad way. It's double dipping in a good way.
You're taking your waste and you're recycling the energy inherent in the waste stream and utilizing it for another purpose.
Yeah.
It's recycling.
Absolutely. And I've mentioned on the podcast a number of times that agriculture is the ultimate recycling system, and the whole idea of turning manure into renewable natural gas is just one really shining star example of that.
Yeah, it really is. Well, Charles, we are so grateful for your time and expertise today as we've enjoyed this great discussion on all things RNG in the transportation market and beyond.
Thank you, guys. Appreciate your invitation to appear on the podcast. Keep your good work up. Keep doing a good job.
Thanks, Charles. And with that, for all of our listeners, thank you all for joining us for episode 12 of Sustaining the Herd. We always enjoy having you join us every couple of weeks, and we look forward to being back with you with another episode in a couple more weeks. Until then, thanks for joining the herd today.